Hello and welcome to another episode of TWIML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Last week was a big week for the podcast. I announced the first anniversary of the show. This week, I want to start the show by thanking everyone who's participated in our first anniversary contest. We asked you to comment on the show notes page or post an iTunes review, and wow, did you deliver. Your stories have been personal, thoughtful, and downright encouraging. I've got a couple that I'd like to share, and really it's so hard just to pick a couple of these, but first, Andrew posted on the show notes page. I've used this podcast to maintain a pulse on current ML and AI. Big thank you for both helping me in my day-to-day, but also getting me interested in ML in general when I first started listening. Heck, I've been listening to this podcast when I was a student, then when I was an intern, and then when I was an entry-level analyst, and then when I was promoted to analyst, and now as a senior analyst. Where I am now is in no small part thanks to this podcast. Wow, that's a ton of ground to have covered in just a year, Andrew. Congrats, we are so proud to have been a small part of your success. This next one has a bit of a backstory. Bill B123 posted a 5-star review on iTunes titled, "Sold on the Deep Interview Format." Bill said, "New interview style format was not initially good. I gave it 2 stars initially, later raised it to 4 stars. Now I'm sold. Great podcast with tons of insights and learning. Keep up the great work, Sam." Now, I remember when Bill's first review hit. The decision to switch to the interview format was really tough for me, but I knew it was necessary for my efforts to be sustainable. Bill's initial 2-star review really hurt. I think at the time him or another user said the interviews were just a bit too fluffy and that I was like the Tim Ferriss of AI. I wasn't really sure what to do with that because I kind of like Tim Ferriss's podcast, but I really took that to heart. And I was pumped when Bill raised his review to 4 stars. And now I'm super excited to see that I've earned Bill's 5th star. Thanks so much, Bill. Starting from nothing, I never imagined this podcast would begin to blossom into such an awesome community of users. I say begin because we still have so much ground to cover and we are truly just getting started. For those who have not yet had a chance to enter the contest, please visit twimlai.com/birthday for more info. Don't forget, first prize gets a bronze pass to the O'Reilly AI conference this June, which is an $1,800 value. Second prize gets a Google Home, powered by AI, of course, and everyone that participates gets a couple of TWIML laptop stickers. The contest ends June 1st, and winners will be announced on the 2nd. If you've posted a review on iTunes to enter the contest, please reach out to us at team@twimlai.com to let us know who you are. All right, this week on the show, my guest is Deep Varma, Vice President of Data Engineering at real estate startup Trulia. Deep has run data engineering teams in Silicon Valley for well over a decade, and he's now responsible for the engineering efforts supporting Trulia's big data technology platform, which encompasses everything from data acquisition and management to data science and algorithms. In the show, we discuss all of that with an emphasis on Trulia's data engineering pipeline and their personalization platform, as well as how they use computer vision, deep learning, and natural language generation to deliver their product. Along the way, Deep offers great insights into what he calls offensive versus defensive data science and the difference between data-driven decision-making versus products. Another great interview, and I'm sure you'll enjoy it. And now, on to the show. All right. Hey, everyone. I am on the line with Deep Varma. Deep is Vice President of Data Engineering with Trulia. And I'm excited to have Deep join us. Deep, how are you doing today?
Oh, I'm doing great. It's, not that hot. This California, San Francisco been hot for the last few days, but seems like the fog is coming back. So I'm definitely doing amazing. How are you, Sam?
Nice, nice. Well, I'm doing very well, and I'm really looking forward to our conversation and to learning a little bit more about how you guys use data at Trulia. Why don't we get started by having you talk a little bit about your background and
Sure.
how you got into working with data?
Yeah, no, I think you asked me a great question because, when I go and I speak in some of the schools to help undergrads or the grads, those who are doing the management. And one of the guys, I think few months back in Berkeley asked me the similar kind of a question that the why data, right? And I think, Sam, it goes back to my reasoning, my mindset from the childhood where I was always looking into, the reasons why this is this, why this is this. And when I get into my master's on computer science, I still remember, there were old databases, which some of like you may know and you may not know. It's DBase or the Fox base.
Mm-hmm.
Those were the early versions or the manifestations of the structured databases coming in. And I was always been very interested. And then entering into my first job in IBM, it's where we are working on those XML data exchange, how we are going to have the data exchange between one entity and other entity, how the web services discovery locator are going to come into the picture. So early on, the foundation was where I been from the get-go, from my own personal desire to look into the answers as well as exposure to the early technologies, get me into the databases, and entering into then my journey where exploring why. And what I realized is at the end of the day, we are always surrounded by data. And the data doesn't mean that it has to be a textual data. The data is how we interact with each other when we are making phone calls to the people, when I'm searching for something. And that's, I think, is 2001 2002 time frame was started getting into my DNA that my God, every day whenever I interact with anyone, anything I do, it's the data. And this is where I got into Yahoo. So then that was a step, where getting into Yahoo, helping advertisers and publishers, try to render good quality ads to the consumers. This is all, again, the platform is, how you understand your consumers better. And then going into my startups and, looking into the data again, where we are looking into, how the data floating from one system to other system, what predictions we can do. So in nutshell, I will say this is how I got into the data. And I think is for me, my behavior, sometimes I'm at a point, Sam, I will tell you, when I go home, my wife have to remind me, honey, you're back home. Don't think from a data point of view. Just think, you're back home. Data reasoning is not going to work here.
That's funny. That's funny. I did some of my grad school work on queuing theory, and my wife is so tired of me analyzing lines and queuing scenarios in banks and grocery stores and trying to tell her which line she should be in. So I definitely relate to that.
Yeah.
So you were in Yahoo back in the glory days, huh?
Oh, trust me, those were the glory days, and I still miss those days because, Yahoo was the center of attraction and the talent was huge there. So I worked there for 4 years, and, unfortunately, Yahoo is no longer Yahoo. But it was amazing.
Absolutely. Were you involved in, did you use Hadoop, or were you involved in kind of the development and advancement of Hadoop at that time period?
So early on, so when I went in, we were trying to, so Yahoo bought this company, Overture, and we were trying to integrate Yahoo's like a platform, backend platform to get the search keywords. So this is where Hadoop pipelines were integral part of the data flow between the systems, that how we get the data from our Pasadena-based company and then into our system. So yeah, I was not deeply, like, I was not part of the Hadoop ecosystem, but I was one of the consumers of the Hadoop system to get the data floating around.
Okay. And then now at Trulia, tell me a little bit about your role. It sounds like, at least from LinkedIn, that you've got a pretty broad set of responsibilities spanning everything from kind of the data platform. I'm sure there's some Hadoop ecosystem, something in there somewhere, to, the data science and the applications that run on top of it. Is that right?
That's fair. And let me walk you through first why Trulia. I think that's, to me, is the biggest piece which inspired me to join Trulia. And do you mind, Sam, if I ask you, do you rent a home or do you have your own home?
I own, yes.
Awesome. I'm pretty sure you're going to relate to this story. So this is way back in 1999 when we decided to buy our first home. It is me and my wife, the data was there, but the data was in storage. Like, I have to go into police stations, I have to go into counties, I have to go into those areas to collect the data. We take this data, then me and my wife sit together, we go through the listings, we look into the neighborhood, we used to maintain our Excel sheet. Oh, let's look into this listing. And it was an cumbersome process, and it was an emotional journey for us to go through this exercise. And it took us months to buy our first home, and we did it finally, right? And that inspired me to join Trulia, because when you think, it's how can we use this data. When I was in my early conversations with Trulia, that was the biggest thing for me, is how I'm going to come and join Trulia and make an impact to build Trulia as more of a data driven product company. And first thing in my mind was the use case of me 1999 buying a home, that Deep, can I make for millions of consumers that journey much more meaningful, much more enjoyable by using this data. So that's how my journey began with Trulia. Now, just to go a little bit more detail into my role in Trulia, I think it's Trulia is our number one goal, and this is where our founders, they saw a huge opportunity to change this marketplace by providing information and insights to our consumers to help them make the right decision, and make this home search journey easy and enjoyable. So, with that mindset, with that goal, what our founder set in forth, we continue. My goal was to continue this and provide amazing experiences to our consumers, and we are investing a lot in our personalization, big data, machine learning platforms to help consumers like me to find their perfect home in much more efficient and better way than I did years back. So that's in nutshell what role is, and I'm happy to dive into more details about those technologies what I'm talking about.
Why don't we start with you talking a little bit about the data products and what are, from a consumer experience perspective,
Sure.
how is machine learning and AI and the various data products that you create on your team, how is that surfaced to the Trulia user?
Yeah, so I think it's, first of all, data driven product companies, Sam, there is a big mind shift needs to happen. And I'm just 3 years back when I joined Trulia, my philosophy was always been to transform and use this data more on their offensive strategy rather than defensive strategy. And I'm going to go into answer your question, but I just wanted to give you a little bit more details, because when you think about the data driven companies, there are two aspects of the data driven company. One is the data driven decision making, and other is the data driven product. And the decision making is more your product analytics, where you launch a feature and then is this feature working or this feature is not working. So my one goal is to transform this data driven decision making more from a defensive to offensive by saying, is this feature going to work? So that's the one component. And the second component, which is the discussion we are having today, is around the data driven product company. And this is where the way it surfaces to our consumers, our average consumer have no idea when they come to Trulia, when they engage with Trulia via mobile web app or our browser or desktop applications. They don't know that we use the data. It is basically pretty much embedded in their user experience. It is embedded when they explore, when they start their search journey. It is our responsibility to understand their behavior, what they're looking into. And what we have done, Sam, is we have built an underlying personalization platform first. And so think about that as our foundation. And, this is where we have our consumers' unique preferences, search criteria, and what they're looking into. Like Deep is looking into quiet neighborhood, good school district in Mission District of San Francisco. That's a personalization platform.
Mm-hmm.
On top of it, we have our machine learning pillars, and there are many pillars what we have invested in machine learning. The first one is our computer vision and deep learning. The second one is our recommender engine. The third one is our user engagement models. And the fourth one is our natural language processing or the natural language generation. So these are the machine learning pillars, what we have. And and then we use all those pieces in tandem, like machine learning pillars, personalization platform, all together to give
Mm-hmm.
that experience to our consumers. When you come to our site and you look into the photos, when you receive an email from Trulia, when you receive a push notification from Trulia, all this is part of our machine learning technologies, which the goal is to engage our consumers and give them much more relevance experience during their stay with Trulia. And I will go definitely this conversation. I will give you more details around each and every component what we're going to talk. But if you have any question, I'm happy to address that first.
Okay. There's just so much in there to
Yeah.
dig into. I like I like the distinction between the decision making versus the products, and you mentioned specifically also this kind of dichotomy between offensive and defensive. Can you elaborate on that a bit
Yeah.
more?
Yeah, definitely. I think is being in the Silicon Valley for close to 2 decades now, and I have seen startup companies coming up, and their focus is mostly around building the products. There are companies like Google's and Facebook's are definitely those who are more data driven, but I have seen early on when the companies start building the products, their focus has never been the data side. They have couple of analytics who are staying behind the scene. Oh, should I change my pricing? Should I make my pricing for this consumer do this? It's always, and after 5 6 years, if they have to raise more funds, or they're about to go public, or when they go public, now the mind shift changes. Oh, what is my differentiator? How
Mm.
I'm going to differentiate my product, how I'm going to bring my consumers back, how I'm going to
Mm-hmm.
engage my consumers. And this is where the offensive strategy comes into a picture, that why not we have the companies start thinking about the data from the get go. What data you're collecting? How do you build? And I think that's a struggle. And that
Mm-hmm.
struggle brings it to the point where companies have to go back and reinvest their resources, their millions of dollars to rebuild their architecture. Because if you think about the data, Sam, at the end of the day, this conversation, what you and me are having, is so much we are talking about artificial intelligence, machine learning. We are collecting this data and we are compacting into a podcast, but these are the signals, right? So there is a quality of
Right.
the data, integrity of the data. How do we take all those things and bundle up so that the organizations are thinking about changing the direction from the get-go rather than after the fact and after years thinking about. So that's the way, I think. And I think I wanted to differentiate between the two aspects which I talked earlier, and I just want to make sure that both you and me are on the same page. One is the decision making, and other is the product building. Both of those facets requires the data. Decision making is our amazing analytics teams. Rather than them working on the data and saying, is it working? I want to transform that to, is it going to work? That's the big differentiation. And the product, what we talked about, that's the second facet of it. Does it make sense so far?
Right. Yeah, no, it does make sense. And, I think the transformation that you described is kind of going, maybe it's a different cut at that defensive versus offensive. And another way, or put another way, you're trying to get teams to stop building, rear view mirror analytics and start, building analytics that predicts what's, going to be happening in front of the windshield.
Here you go. I think you nailed it better than me, right? It's the right way to explain it, right?
Yeah, and I think that is, that transformation is something that's happening very broadly in, industry, not just in technology companies, but also in enterprises. And it's, that need to look out the windshield and not be stuck, reading reports that took weeks to create that reflect the previous quarter and aren't really even relevant anymore. I think that's why, enterprises are kind of grasping onto, machine learning and AI based solutions as a way to kind of give them that forward looking view.
Yep. And I will add one more thing, Sam, here. So also, when you think about any enterprise, any startup, any technology company, at the end of the day, all the work is done by the people and you have the limited resources, and, you are building a product. Rather build a product which is going to work in the marketplace. Like no one has this magic wand to say this is going to work, but this front, this offensive strategy, or whatever way we want to say, it helps us to align our resources in the right direction too, so that we can change the direction of our ship going in the true north rather than go in the south direction and then bring it back.
Right. Before we dive into the platform that you built, one thing does strike me is that, perhaps more than some other companies, Trulia's product, its offering is data, right? And I'm making some assumptions, but I'm assuming that you're, sourcing, a bunch of different feeds. And you even describe some of these, your MLS listings, your county, data feeds, maybe pulling in from good schools and other sites that are producing aggregate data on, schools and crime and all these things. Like your fundamental data is so fundamental to the things that you do. Before you even get to how do you what have you built and what have you learned about aggregating all of this data, and a little bit of context for this. I often hear, or I recently produced an event called the Future of Data Summit, and we had speakers talking about different aspects of AI, and several of them got up and said, well, in order to do machine learning and AI, you have to have the data, and I think that's true, but it kind of glosses over the fact that sometimes you have to get the data, it's not just sitting there waiting to be exploited. You have to go and find it. And it seems like a lot of what you did is go and find it. And so, how did you, to what extent does your team get involved in that? And what's the platform for enabling that?
Yeah. I'm so glad talking to you, right? Because you're nailing down exactly the points that I'm passionate about. So when you think about, there are two pieces to the data, and I'm going to make it very simple first to start with. Like when someone goes to Google and they search on a Google, the first thing what they're doing is they are giving the search engine their intent, what I'm searching for.
Mm-hmm.
And then Google has this content, which is they went ahead by crawlers and all those things, by building the relevancy and all those things. So
Mm-hmm.
consumer gives the intent. Google has this massive databases of the content, and then the magic
Mm-hmm.
in the middle, which takes the intent and content and matches up, which we call as a relevancy, and give it to the consumer, where consumer feels happy about it, right?
Right.
Now,
Right.
in the same context, Trulia also had the two parts of the data. One is the consumer, for whom we are building this product, and then the content, where we get this content from. And I think, this is the listings, as you talked about. This is the public records, which you talked about. Now, schools data, the crime data, the commute data. I think that's the difference between 1999 and 2017, where we have the technologies like real-time messaging systems like Kafka, we have Storm topologies or the streaming systems, we have those Hadoop or Spark technologies, where we can make it easier to ingest those data into our
Mm-hmm.
system. So we have, and this data is pretty open, right? I have written on my blog, roughly we have 2.5 million active for sale listings on our system. So
Mm-hmm.
across US, you have agents, those who are working with consumers to sell their home. They enter this information into MLSs, how this data comes in from MLSs to our system. Then, when you sell your home, when you buy your home, you pay your taxes. You have these assessments and the taxes which are going into the counties, how we get this data. So I think my team involves, at the end of the day, whatever you see on Trulia's side, it is my team's responsibility to use technologies to bring this data in the raw form first, and then enrich this data. Because when you think about, you are MLS1 and you will come and say 1234 First Street, and you can spell First Street as FIRST, or someone just come and write number one First Street. So we have to have this magic in the middle to join all this data and say this data is for this property. And then once we know that, the geolocation, when we had the address cleansing, address normalization, and then when we work on the enrichment piece is, for this listing, this is the historical information about the property. This is when the property was sold last time. This is the taxes information. This listing is 2 minutes away from the public transit system. This is the school. And then we go through this enrichment process. Once we had that enrichment process, it goes into our indexes, which is, we use our Solar technology, and
Mm-hmm.
we have built, our API layers on top of it, which can take up to 10 to 15,000 requests per second to serve our front end technologies like web apps and, mobile web or whatever it is. So what I explained it to you on surface, it looks like a big process which takes days and days and days. Interestingly enough, when the listing hits the marketplace, by the time it goes from one point with the enrichment to the front end, it is less than 15 minutes where we show the data. So this is
Wow.
all because of the technologies what we have enables us to give this content to consumers faster. So I just
Mm-hmm.
talked about the content piece, which is, all the data flowing around. And I think most likely when you're ready, we will jump into the intent piece, which is the personalization and all those. But does it
Mm-hmm.
make sense so far?
It does. It does. And I still have tons of questions on that content side.
Let's.
Um, uh, so thinking about the various ways that you likely get data, I'm imagining maybe three, and there are probably many more, but I'm imagining, some data is coming you via feeds. maybe this is like the listings. Some data is coming to you via streams, and some data is coming to you via in batches. Like, can you characterize like how much of the data is each, and is there a category that I'm missing in this, and then like where do you land it? How much of what you're doing is real time stream based kind of processing?
Yeah, so I think it's depends upon the set of the data. Like, so when you think about the listings are majority of our listings are the stream based, which are real time, because listings hits the market. But then when you think about the public records, which is deeds, assessments, taxes information, that is mostly the batch based what we have. And then you have the school data, which is not it's not changing on a daily basis. That's a feed based. Then you have a crime data, which is more the streaming thing. So I think
Okay.
it depends upon the data set. So we have the technologies where we define if the data needs to be refreshed more frequently, we use the streaming technologies. And otherwise we use batch based systems. We have invested in building some of the systems uses the Lambda technologies. So this is the real time plus the batch based. On a nightly basis we run the full Lambda and then make sure that there is the accuracy on the quality of the data being implemented. There are some places we also use Kappa. I don't know if you heard about Kappa. So Kappa is also, the real time, but the batch based. So I think it's at the end of the day, my team have built those pipelines. Some pipeline uses, the Kafka messages to Storm topologies, the streaming technologies. Some places we have the Spark where we need the data to be processed much more faster. So I think it is at the different data set have the different refresh SLA, and based on those refreshing SLAs, we tend to bring it to our systems.
And before we move on, why don't you give us a brief overview of Lambda architectures? And you mentioned Kappa as well.
Yeah.
And you mentioned Strom as well,
That's
just for
streaming.
folks that haven't come across those.
Sure. So I think let's start with the streaming, right? So I think what's happening is the streaming, the real-time streaming and the processing. So when we have those messages, so think about if there are 2.5 million active listings are there across, US, when they hit our system, they are coming into our messaging layer, and there are different messaging technologies are there. We are using Kafka, Kinesis, mix of that. From there, we move into the streaming, and the streaming can be Spark or it can be a Storm topology. There is a place where we use Storm topologies because when the listing hits, remember early on I was telling you that we need to do address cleansing, address normalization, and then the enrichment. So this is where we have the spouts and the bolts of our Storm topology, where spouts are the one which is ingesting the data, and then the bolts are the one which are making the decision making. I have to perform step XYZ. So Storm topology helps us in the real time take the stream of the data, perform the enrichment, perform the cleansing, and then go and persist it into our new messaging layer from the data can be sent over. So that's the Storm topology. Lambda is Lambda is being there in the marketplace for long. And what Lambda means is, look at on a daily basis, when we are getting millions and millions of messages and, it comes into our system, it is very important for us to maintain the accuracy and the quality of the data. So on a nightly basis, we rerun the whole data set, what we have collected on this day, just to make sure that if there are gaps, we fill those gaps using the Lambda architecture. And which will give us the higher level of accuracy and the quality of the data coming into our system. So the only difference is in Lambda, you have to write your code base differently to consume the batch based. But when you move into the Kappa architecture, you don't need to write the separate code base. You can have the similar code base, which is used during the real time streaming, and you can use the same code base for your batch based topologies also. So Kappa enables you to do that. So that's how we use those three technologies which I just talked about.
Okay. All right, great. That's we'll include some links to these in the show notes. I've come across Lambda architecture before, but Kappa architecture is new to me.
Yeah,
so
it is.
That's
It is
pretty
coming
interesting.
pretty. Yeah, it is coming pretty new in the marketplace. Last couple of years, I
Okay.
see people using it more.
Okay, great. So you've ingested all of this data, and you've used technologies like Lambda and Kappa architectures, Apache Storm, and other technologies, Kafka queues and messaging, and all these things to get all this data in to enrich it. And where do you land it?
So, if your question on the landing is where do we persist it?
Right.
So we persisted in our Solar index. So Solar is the search technology, and
Yep.
when you think about, we have this millions and millions of rows coming in. Do we need to, if there are 100 attributes in a row, do we need to persist everything in the Solar? So we basically, all the searchable things we store in our Solar, and then the things which are not searchable, which are just an augmentation of the data, can go into any of the NoSQL databases or some places where we feel the data is much more structured and we don't need, we uses the relational databases also, where the volume is pretty small. So we use MySQL, and that's how we persist. So we use, Solar, HBase, Redis, DynamoDB, MySQL, and I'm pretty sure, Aerospike is another one which we recently started using, the key value pair systems. So we use a very wide variety of the databases here in Trulia. And again, it all boils down to the use cases. Where do we need to store what?
Right. So you have individual teams that are working on, given products that are surfaced through the site, and they choose whatever data store makes the most sense for their use cases. Is that right?
Yes and no. So, right. So, for example, if we know the latency is a big thing for us, then storing that in HBase may not make sense. So people may decide to use, Redis, or they may go with the DynamoDB. And so I think we have some guidelines around, like, the biggest thing for us is build the databases and see the latency, right? Because we have the API, we have abstracted all the data as an API layer on top of those systems, so that when front end team comes and says, give me all the data for this listing, then this API goes across the different systems or the databases to bring the data, stitch it together. So latency plays a major role, but to some extent, what you were trying to say, yes, the decentralization of teams definitely enable us to have teams pick the technologies what they want to pick. We don't put so many guidelines except for the latency as one of the prerequisite, making sure that we pick the right technologies.
Okay. All right. So then all that in place, let's jump into the personalization platform and the stuff that you're doing on top of it.
Here you go. That's the fun piece, right? It's right. I really love that piece. So I think now what we talked about in last few minutes was mostly around the content, right? So now we need to start thinking from an intent point of view. So when consumers, they come to Trulia, when they are interacting with our website or mobile app or mobile web or email, at any given moment of time, what we have seen our consumers are generating those signals, and the signals are nothing but their intent. You know,
Mm-hmm.
Deep is looking into, a listing in Noe Valley of a San Francisco, which is in quiet neighborhood. That's a signal. And then Deep is looking into photos, and what kind of the photos Deep is looking into. So we have this stream of data flowing into our system, what signals, and what we internally call those as an events. And events are generated by consumer interacting with those products. So we basically take those events, and our personalization platform collects those events. The events are, just think about, if Sam goes to Trulia and you look into some site, on an average, like when you look into a specific property, Sam
Mm-hmm.
is going to generate an average of 20 events, within few minutes of your interaction. So we had this, again, the real-time messaging layer, which collects those signals. And, we have, Trulia has millions of consumers, which are active on a monthly basis. So when they send those signals, we bring it to our Kafka layer. And from the Kafka layer, we basically brings it again. We use streaming technologies like Spark or Storm, again, for the intent side of the technology stack too. And this is where either we have the real time machine learning models in place, or we have some aggregated systems where those signals are getting evaluated, right? Okay, we just see Deep, or we saw an anonymous consumer. We take all those data and then we persist it into our caching layer, where that caching layer, which can be, so HBase is our persistence layer for all the personalization platform, but then the caching layer
Mm-hmm.
is the Redis, what we have.
Okay.
So if Sam is pretty much active on our site, then Sam moves from HBase to Redis. That's how we make, because of the latency. So
Okay.
this, at the end, this personalization platform stores Sam's unique preferences, Sam's search criteria. Is, Sam is looking into, your Sam owns this 2-bedroom, 3-bath in St. Louis area in a quiet neighborhood. Sam is looking into this. So I think that's the personalization platform is a very foundational aspect which drives rest of the other thing. Then on top of, I'm going to move over to machine learning systems. Is that fine now?
Sure. Sure.
Yeah. So now when you think about this personalization platform is put into place, which is like an engine which is working on a daily basis by itself. Our first machine learning platform is computer vision and the deep learning.
Okay.
And this is where we've been leading this industry in the computer vision and the deep learning for years, where, computer vision, right? It's a system which we have built, where we have, trained our systems, machines, to look into photos, and they can see, oh, I'm looking into a photo of the swimming pool, or I'm looking into a photo of a kitchen which has a granite countertop. So
Mm-hmm.
that's the computer vision what we have implemented. And then what we do is all those unique attributes, the data which comes out of the system powers our homepage. And in our homepage, you will see what we call as collections. The collections are nothing but the group of properties which we bring it together. So you may see collections like, homes with swimming pools, or home with remodel homes, or homes with kitchen granite countertop. So those are the collections which we powers our homepage. And the more our consumers engage with these collections, the more insight we get into our consumers. So that's the one use case of our computer vision. The
Mm-hmm.
second use case of our computer vision is, I'm pretty sure you, me, and all the consumers, when they start their home buying journey, the first thing they do is they come into site like Trulia and they search for neighborhood, then they go to a listing, and then they start looking into the photos of the home. That's how the journey starts. And if
Right.
if those photos are not engaging, and if those photos are not telling story, consumers are going to lose their interest and they will keep moving into the second and third. So what we have done is, we using conventional neural networks, CNN models, we have invested in understanding, the scene types of the photos, whether the photo is appropriate or not. Like someone can just put a photo of a dog, so we say, great, we can see it is not a photo of a home, it is a photo of a dog. And then the quality of a photo, is this photo
Mm.
is blur, is this photo is much more clear. So these three things what we take out from our CNN models is the quality of a photo, appropriateness, and the scene type. We score those things, and then the highest performing photo, what we call as our hero image. So what we
Hmm.
do is, most attractive photo, when you start your journey, we put the most attractive photo for you first, so that your engagement becomes much more better with Trulia. So that's the second
Hmm.
use case of our machine learning, computer vision. And what we have seen by investing in those technologies, there are double digit increase in inquiries for our listing. So that's the one piece. Make sense so far?
And is that lift based on? Do you think primarily just getting the right listing in front of the right person who's likely to like it, or is it getting rid of or kind of suppressing the listings that aren't good in general? Is there any one factor that drives the kind of results that you've seen?
Yeah, so I think our relevancy is driven mostly by the consumer's behavior, what consumers are interested into.
Okay.
And so we basically just based on the consumer needs, and this is where the personalization platform comes into a play to drive that computer vision on the serving side, what to serve to the consumer.
Mm-hmm.
Make sense?
So yes, so two different users, say my wife and I are kind of collaboratively shopping for a home, as husbands and wives tend to do. She might, when she goes to the site, she might see pool pictures first, and I might see kitchen pictures first, or what have you, depending on what our interests are. And these aren't interests that we've explicitly shared with you. They're interests that you've derived from the various signals from watching the way we interact with the site.
That's fair. And that's how basically the more you engage, the more we know about you. Because if you come for the first time, we really don't know about you, right? It is basically
Right.
we need to reach enough confidence level to serve you the right content. But yes, your assessment was pretty good.
Mm-hmm. It's funny. I can't help but the thing that as someone who travels a lot and as a result uses Yelp a lot, I am always complaining about just how dumb the Yelp app is. And I don't think I've ever done it on the podcast before, but I wish they were doing more of what you're doing. When I land in a city, I pretty much like open up Yelp and like type in Thai or type in Indian every time trying to find a place to eat. And I always wonder, like, why doesn't it just show me what it knows that I'm going to be looking for, or what it should know that I'm going to be looking for? So maybe I'll use that rant as a segue into like, what are the challenges that you've seen, or what do you think, what's the barrier to, more companies, having technology that enables them to better know and personalize to their customers?
So just to understand, so your question is, what is the biggest barrier to investing in this kind of technologies?
Yeah.
Yeah, I think it is mostly around making sure. Remember, early on we talked about the data driven product companies, that
Mm-hmm.
how do you understand the strength or the data what you have with you. And I think it's the first, it needs to start from the top level, the commitment from the top level. That's the area we want to invest in. And the
Mm-hmm.
second thing, Sam, is rather than boiling the ocean, right? Oh, let's solve all the problems in one go. Pick the small use cases to evangelize within organization, so that, product people and the other stakeholders can bought into those concepts, because AI or the machine learning is still in very infancy stage. We have not
Mm-hmm.
reached a point where everyone understands. So my recommendation to the people is definitely, bring an evangelist, build the small use cases, show the value prop, back it up with the data, build slowly and gradually build a tsunami. And when this tsunami is going to hit, then everyone is going to bought into this. So that's the way what I
Mm-hmm.
look into.
Yeah, that's a great articulation of the process. So you guys have also done some writing on your engineering blog about how you use natural language processing,
Yeah.
and in particular natural language generation. Can
Yeah.
you talk a little bit about that use case?
Sure. So, so I think, thinking about, so it all starts again for us. We don't start from thinking about machine learning first. We always start from thinking about the consumer first. That's the number one goal.
Mm-hmm.
And what we started seeing, there are thousands and thousands of cities or neighborhoods across US. When consumers come to our site, they're looking for more information about this site. They're looking into more information about that neighborhood. And we said, great, now how can we use the data what we have to build the story? And one way you can do is, you can have the human beings as editors and let them write the stories about the cities and the neighborhoods. But when you go into this kind of a massive scale, there is no way that's going to work. And that's where we said, okay, great, now let's rely on the machine learning technologies to solve that problem. And this is
Okay.
where we leaned on our natural language generation system. So what we do is we look into a location and we have built this feature extractor. The feature extractor look into, what are the restaurants close by, what are the commute systems looks like, is the price going up for that neighborhood, is it going down? So we extract the features, and then once those features comes out, what we have is a document planner which looks into the features. We have a document planner. um, but before we go into a description generator, we have built our content bank. So think about the content bank is where we build the sentences based on the features. That if we say this, like this neighborhood is a Victorian style homes, so our content bank is going to have a sentence which will say Victorian, this neighborhood has Victorian homes. So we have this content bank, and that content bank is built based on some of the crowdsourcing, which definitely we do, but we use our data mining and machine learning technologies to look into the data to build those content bank. So now think about the document planner coming out for a neighborhood or a city or a specific location which has all the feature sets. We have a content bank, and this is where then we use the description generator. So description generator take the document planner, take the content bank and use the NLG to generate the content for that specific location. So that's how we use NLG, and it's been going great on that front.
So what I think I hear you saying, and this can be instructive to folks that want to use this, is that as opposed to throwing trying to throw a bunch of data to some natural language generation system and kind of hoping for it to generate something that makes sense, you guys have broken up the problem and structured it, in such a way that, first you're identifying the, you call them features of a given neighborhood, maybe not features in the sense of a training a machine learning algorithm, but they're, just attributes of a neighborhood. And you kind of structure your descriptions, so that, you will highlight one or more of these attributes. And then the content bank, what I thought I heard was that you kind of have a set of templates or rough structures of the way you talk about different things. So you kind of have a template for how you talk about, a neighborhood composition in terms of its architecture, maybe some templates for restaurants, things like that. And then, all of that, those attributes that you decided to highlight in a given description, and this set of templates are utilized by this description generator to create something that, sounds more human and is more readable and usable than, what you might get if you just threw all the data against a neural net of some sort.
Yeah. One clarification, the feature extractor, it uses the data mining technologies to extract the attributes what you're talking about. So yes, it goes into a neighborhood, it uses the data mining, it generates the attribute, and you're right, spot on the content bank. In a simple form, you can think about the templates, or you can think about, which defines the much more vocabulary, which is easily understood by our consumers.
Mm-hmm. That's great. That's great. Well, I know you're bumping up against a time constraint here. I think this is a great, use case. We spent a lot more time on the, data engineering, data acquisition side than we usually do on the podcast. And, I enjoyed geeking out a little bit on some of that stuff. But it sounds like you guys are doing really, really awesome things. And so thank you so much for being on the show and sharing them with us.
Great. Thanks, Sam.
All right. Thanks, Deep. Bye-bye.
Yeah, bye-bye.
All right, everyone. That's our show for today. Once again, thanks so much for listening and for your continued support. Don't forget to leave your review or comment to enter our 1-year anniversary listener appreciation contest. The full details can be found at twimlai.com/birthday. And of course, you can leave your questions and comments over on the show notes page at twimlai.com/talk/2525, where you'll find links to Deep and the various resources we mentioned in the show. Thanks so much for listening, and catch you next time.